Okay, in your notes you have some stuff about unit circle. I think we're going to just do some unit circle like practice tomorrow, so don't even worry about that. We'll talk about the unit circle then. All right, so we're going to look at if sine is 3/5, find the possible values for these different things. Okay, so sine of 3/5 means that our opposite over our hypotenuse, our opposite would be 3 and our hypotenuse would be 5. So where could that be? So if we have all 4 of our bow tie reference triangles. We would look and see, okay, so opposite would be our y value, right? It would be this one here, this one here, this one here, and this one here. Okay, so where is our opposite positive? Well, our opposite is positive here. This is positive, this is positive. This one would be negative, and this would be negative. And remember, our hypotenuse is always positive, so the only way for us to get positive 3/5 is if the 3 is positive, okay? So our only 2 options for triangles for this one are these 2 triangles, okay? Those are the only ones that could give us 3/5, positive 3/5. So this would be 3. Let me just erase those positives. Okay, so this would be 3, and this would be 5. And then we recognize, hopefully, that this is a 3, 4, 5 triangle. You could use the Pythagorean theorem to find the other one, but this is a Pythagorean triple. So it's a 3, 4, 5 triangle, so that means this one is 4. Okay? Now, on the right side, that's a positive 4, but on the left side, what is that? Well, that's an x value, and that x value is negative, so that's a negative 4. But if you look at either one of these triangles, the sine of each of these triangles is 3/5, right? Opposite over hypotenuse. Okay. So what are our possible values for cosecant? Well, cosecant is 1 over sine, or the reciprocal of sine, which means that it is 5/3. There's no other option for sine or for cosecant because it's literally just the reciprocal. But what about the cosine? So now we have, again, these 2 triangles, and we have to decide which one could it be. Well, it could be either one, right? So if we went with the right triangle, the cosine of that triangle is 4 over 5 because it's adjacent over hypotenuse. And if we went the left side, it's negative 4 over 5. So we're just going to say it's plus or minus 4/5. It's either one of those. Okay, and then tangent. Again, if we went with the right triangle, our tangent would be 3/4. If we went with the left triangle, our tangent would be negative 3/4. So we're just going to do plus or minus 3/4. Okay, so sometimes we have to work backwards because we have these equations where we say cosecant of some number equals negative 2 over root 3, and we have to figure out what could this triangle possibly be. So again, we think cosecant is the reciprocal of sine, and so sine is opposite over hypotenuse. That makes cosecant hypotenuse over opposite. Okay, so let's draw some triangles, reference triangles, and let's figure out which ones of these would have a negative hypotenuse over positive opposite. Okay, so all of our reference triangles are part of the bow tie. I just drew them backwards, bow tie. Okay, those are really sloppy, but we'll just call them good. No, we're not. I can't handle it. You thought I could. I can't. Okay, so here's our different reference triangles, and we have to decide which one could possibly be this cosecant one. Well, let's see. We've got to have negative well, we can't have a negative hypotenuse, so there has to be negative opposite, right? Okay, because hypotenuses are always positive, so we look at all these, and we look at the opposite of these. Those are positive, those are negative. Okay, so the only reference triangles we could possibly use are these 2 bottom ones. Let's redraw that one. So those are the only 2 triangles we could possibly use. And so then we know that hypotenuse has to be negative, or has to be 2, right? And the opposite has to be root 3. Okay? And those are both negative. And so it's saying what function could this possibly be? Which angles are going to give us this? Okay, so if we look at this, we realize that that makes, this is like a 30, 60, 90 because it's, you know, root 3 and 2. So this would be -1 and this would be 1 because it's a 1, 2, root 3 triangle. Okay. And so then we realize, well, so this is a 30, 60, 90. The smallest side is 1. Therefore, the smallest angle right here is 30. It's going to be there. And the next biggest is 60. So it's going to be there. So this is a 60-degree angle right there. Okay. So our reference triangles are 60-degree triangles. So our options here are like this triangle, or not this triangle, this angle that's coterminal with that triangle. So what is that? That's 180 plus another 60. So 180 plus another 60 would be 240. So that would be 240 degrees. But it says on the interval 0 to 2 pi, oh man, that means we're going to have to do this in radians because we can't report degrees when it asks for radians. So what is that? So we're not going to do degrees. So that's 180 is the same as pi. And then we have pi over 3 more than that. So we're going to have 3 pi over 3, like a whole pi, right? And then we're going to add another third of a pi. So we're going to have 4 pi over 3. That's the first one. That's the green one. Okay, and then the other option, and this is getting really messy, I know, is this triangle, or this angle right here. So it goes a whole pi, and then it goes another half a pi. So now we're at 3½ pies, or 3 halves of pi. Okay, and then it goes basically almost all the way to 2 pi, but we have a third of a pi less than 2 pi. So we could do it that way. Or we could figure out that it went 3 halves of a pi and then another 6. And I totally lost you there, I know. So let's just do it this way. Okay, we had 2 pi total, 2 pi, which is the same as 6 pi over 3, okay? And we're 1/3 of the way that, like, we're almost there. We just have, do you see this? Like, we only have 1/3 left, a third of a pi left. So we have everything except for a third of that pi. So that makes this 5 pi over 3. So our two possible answers for this one is 4 pi over 3 and 5 pi over 3. Okay, that was ridiculously long. All right, if cotangent is root 3, so again, we're going to draw our reference triangles. We're going to look at our bow tie. And we're going to say which ones of these could possibly have a cotangent of root 3. So remember that tangent is SOHCAHTOA, so it's opposite over adjacent. Therefore, cotangent is adjacent over opposite. Okay, so we have adjacent over opposite, and we need these to be positive. We need to be positive in the end. So we look here. Adjacent is positive, and opposite, adjacent is positive. There we go, and opposite is positive. Here that we have negative positive, this is positive, this is positive, that's negative. So that's not positive, that's negative. Goodness gracious, I'm trying to rush and it's not working. Okay, this is negative. Okay, so which places would we have, if we did adjacent over opposite, would we have a positive value? Well, here we'd have positive over positive, here we'd have negative over negative. So either one of those. So our two reference triangles that we could possibly use are those two. Those are two, because we would have a positive over positive, negative over negative. Okay. So then we need to have it to be root 3 over 1 when we do adjacent over opposite. Okay, so here's our angles. So we do adjacent over opposite. So this needs to be root 3 over 1. Root 3 over negative root 3 over negative 1. Those are our options. Okay, and then we figure out, okay, this is a 30, 60, 90 because we see a root 3 and a 1. So this is going to be a 2. 1, 2, root 3. Okay. And then we say, okay, so this has to be the 30-degree angle. That has to be a 30-degree angle so that we can have the 1 across from it. And then, so what are these angles? Well, the first one is just 30 degrees, right? So it would be just this one. That angle would have a cotangent of root 3 over 1. So that angle is 30, or pi over 6. And then we have this other angle that goes all the way here and ends right there. So how much did it go? It went a full pi and then another 1/6 of a pi. So that would be 7/6 of a pi, right? So those are our two options. Okay. So we're solving here 2 cosine squared minus 1 equals 0. So one of the biggest things you need to remember is cosine squared means cosine of theta squared. We just have to write it that way because if we wrote cosine theta squared, it would look like theta was being squared, and that's not what's happening. We're squaring the entire function cosine squared. So we have to solve this one for theta. I'm trying to get theta all by itself. So we're going to add 1 to both sides, and we get 2 cosine squared theta equals 1. So then cosine squared theta equals 1/2. And so again, since this is really cosine of theta squared equals 1/2, we can just take the square root of both sides. And we get cosine of theta equals 1 over root 2 plus or minus, right, because it's the square root. And so then we look at which angles are going to give us these. So again, we're doing this without a calculator. You can't just like put in inverse cosine and bust it out, which would be awesome, but we can't. So we have all of our reference triangles. And which ones of these could possibly give us plus or minus 1 over root 2? Well, actually all of them. Because if we have positive, it could be, 2 of them, and then if we have negative, it could be the other 2. So all 4 of these triangles could potentially give us either a positive or a negative 1 over root 2. So remember that cosine is adjacent over hypotenuse. So our adjacent side is going to have to be 1, and our hypotenuse has to be root 2, okay? And that would be a negative 1. So you could see that this one could give us negative 1 over root 2, and this could give us positive 1 over root 2, okay? So then we look at what each of these are. So all 4 of these angles are going to give us what we need. So we might recognize this as a 45, 45, 90 because it's a 1, 1, root 2. So that's 1, negative 1, that's negative 1, and that's 1. So this is a 45, 45, 90. So again, we're just going to start. What is this angle right here? Well, that's 45, so that's pi over 4. Okay, then what is this angle over here? Well, that is almost to a full pi, but we have like a 1/4 of a pi. See this? This is a 1/4 of a pi hanging out here. So instead of 4 pi over 4, we have 3 pi over 4. Okay, and now we're going to look at this one right here. So again, we went a full pi, and then we went another pi over 4. So instead of 4 pi over 4, we have 5 pi over 4. Okay, and then last but not least, we have this one all the way around here. And so we can say, all right, we went almost a full 2 pi, but we have this little pi, this 1/4 of a pi left. Okay, so if you eat almost a full 2 pies, and you just leave a 1/4 of a pie left, how many pies did you eat? Well, you ate 7/4 of a pie, right? So these are all 4 angles that would make those, that would make that true. So the last little joke here at the bottom is, in this unit, you must be very careful with your signs. But really, you have to pay attention to positives, negatives, and all of that stuff. So just be really cautious of those and watch those carefully. And so again, we'll talk about the unit circle again in class. We'll get some really good practice with the unit circle.